Oh, why hello there. Is it still recording? Please be. Yes, okay. Still recording. Oh no. Okay, let me erase this. And let's start from the top, I guess. I got freaking sticky key. Shut up! Don't do it. Let's increase the size of my eraser. Magic finger. Okay. Now to erase this line. And decrease the size. Oh god, I'm going too slow. I'm very sorry. I need to really work on that. Here we go. There we go. Alright, ready? Let's begin then, shall we? Hello everybody. I'm very proud to present Trigonometry, a collaboration with Chamgus. And quite clearly we are learning trigonometry. And hopefully you will get out of this class the basics as well as the advanced understanding of trigonometry and how to use it. I'm going to be covering the basics. Ham is going to be covering the more advanced stuff. Let's go over what you need to know. What you should know: Algebra 1, Geometry and Graphing. You need to know how to graph on the coordinate plane. Pretty simple. You need to know geometric stuff like 30, 60, 90, 45, 45, 90. You need to know Algebra 1, meaning quadratics, and how to, find angles and stuff like, well, that's geometry. But yeah. And today, what we're going to be learning is what radians are relative to degrees and how to calculate radians, how to graph angles on the unit circle, and how to find basic sine and cosine values. Let's begin. So, let's start with step 1. What radians are relative to degrees? Oh boy. So, what is a radian? Well, a radian is a way of measuring an angle, just like in degrees. But it's a different measurement, and it works better on, circles and with trig. So let's begin. Let's start with a very basic principle. It's called 2 pi radians. 2 pi radians are equal to 360 degrees. Okay? Pretty simple right now. Now what we're going to want to do is just make, because this is going to be super useful, is, oh god, we better get to angle 0 and make a frickin' massive square. Oh god, that's not big enough. Oh no. Yes, that's what I like. Okay. That looks like the middle, right? Oh no. Oh god. Please. No. It's not the middle. Okay. Sorry, OCD kicking in here. I'm still going incredibly slow, as usual. But, we will get started, and then we will be speeding along. I should have set this up earlier. That's fine. You guys can just skip through. I'll say when you can skip. Let's just start. Okay. Right. And then I remember how to make a circle. You drag to this corner. Blammo. Good enough. More than good enough. Okay. Let's start with basic principle. 2 pi radians equals 360 degrees. Okay. Now, I'll explain more about the circle later. Now let's calculate some basic values, right? Let's go every fourth. So 90, 180, 270. Right? Let's start with that. 90 is 360 divided by 4, right? So we're dividing by 4 on this side to get to 90 on this side. We divide on that side. 2 pi over 4 radians is equal to 1 pi over 2. So pi over 2. Pi over 2 radians. I'll just write RAD for that because it's radical. 180 degrees. Well, you're dividing 360 by 2. So you divide 2 pi by 2. 2 pi over 2 is pi. 180 equals pi radians, and then 270 degrees, well, that's 3 times 90 degrees. So you multiply pi over 2 by 3, so 3 pi over 2 radians, right? And so that's what we have for our values. Now let me explain what this massive circle is doing over here. How far can we zoom in? Whoa, this is a very big circle. Oh yeah. Okay, let's start by labeling our coordinates. So this is a circle centered. Let me label the origin. Centered at the origin with radius 1. So let's think, where would this be? Well, that's 1 away from 0, 0, but it's to the right, so 1, 0, right? Oopsie poopsie. Okay, there we go. This 1 up, 0, 1. This 1 to the left, so -1, 0. Hopefully you can see that. Oh god, that's tiny. Oh god, okay, that's fine. You should just remember this, because this is going to be kind of crucial. Down here, 0, -1. This one's a bit bigger. They're all tiny. Anyways, now let's label where they are in degrees and where they are in radians. So okay, so 1, 0, so this flat horizontal line to the right, so on the unit circle, 1, 0 is at 0 degrees and 0 radians, right? Because if you multiply both sides by 0, you're going to get 0. 0 degrees and 0 radians. And when we're calculating degree measures, we always go counterclockwise. So then this, oops, my god, okay. This becomes what? Well, you're going a quarter circle that way, so 90 degrees. Or pi over 2 radians. Here you're going a full semicircle, which is 180 degrees. Oh my god, why are you doing this? 180 degrees and pi radians. Can you see that? Wow, you can actually see it. This one you're going 3/4 of a circle, so 270 degrees or 3 pi over 2 radians. Okay, so now we have this. What do we do with this? Well, let's label some more degree angles, which are going to be crucial in our step of starting to calculate sine and cosine values and finding angles on the unit circle, which how to graph angles on the unit circle based on, radians. So let's calculate the 45 degree angles. What would that be? I mean, like every 45 degree interval. So we have 45 degrees first. Then we have 135, right? Because we've already calculated 90. And then we have, what would that be? 200 and, I can't add, oh my god, 200 and, why can I not add? God, 225 degrees. Sometimes you people must worry about me. 315 degrees. Right, and then we're going to have 8 more angles after this. Trust me, it gets easier once you get used to it. 45 degrees. How can we calculate 45 degrees? Well, it's in between of pi over 2 and 0. So it's the average of them. So pi over 2 plus 0 over 2. So pi over 2 plus 0 is pi over 2. And then over 2 is, precisely right, pi over 4. 135 between pi over 2 and pi. So then that gets us 3 pi over 2 when we add them, and then we average, so divide by 2, so 3 pi over 4. You get the gist, we are adding pi over 2 each time, right? So 3 pi over 4 plus 2 pi over 4, which is the same thing as pi over 2, is 5 pi over 4, and 7 pi over 4. Get it? Because we're adding pi over 2 each time. Because we've already calculated one interval for 45, now we calculate the other. So let's. Okay, so, my god, I keep clicking the wrong one. Alright, so start at 0, 0. Oh no, please. Okay, that looks good, right? And now we go down this. Oops, okay, I really don't like that. Okay. Bam. Jesus Christ, I'm just not having a good day today. Okay, here we go. We've got intervals of 45. We'll label them after we do the next one. And the next one we're going to do is multiples of 30. So, here we go. Let's do, we need 30. Oh my god, okay. Let's get that away. 30 degrees. 60 degrees. 120 degrees. 150 degrees. 210 degrees. 240, we're almost there. 300 degrees. And 330 degrees. And there's a pattern, so we can fill all these in after just 2. So let's do this in terms of 30 and 60, because half of them are multiples of 30 but not 60, and the other half are multiples of 60 and 30. So let's do multiples of 30 first, right? We're adding 90. Well, okay, I mean multiples of 30 but not multiples of 60. So that's every one that every other one. So this one, this one, this one, this one. I mean, oh, I missed one. And wait, what? Give me a second. Oh, I've messed that up already. You must have so much faith in me. Okay, so that one, this one, this one, this one. Okay? So, wow, that's probably a bad idea, actually. So, let's not do that then, shall we? Let's just do them. 30 degrees, that's 90 degrees over 3, right? 90 degrees is pi over 2, and then divide that by 3, we get pi over 6. 60 degrees, well, you're multiplying 30 by 2, right? So pi over 3. You have 120 degrees, multiplying 60 by 2, so 2 pi over 3. 150 degrees, you're multiplying 30 by 5, so 5 pi over 6. 210, you're multiplying 30 by 7, 7 pi over 6. 240, you're multiplying 120 by 2, so 4 pi over 3. 300, you're multiplying 150 by 2. 10 pi over 6, so 5 pi over 3. 330, you are multiplying. Well, no, not multiplying. You're adding pi over 6 to 5 pi over 3, which gets you 11 pi over 6. Right? So there we go. This is every angle. Trust me, you will get used to it. Eventually, it makes sense because it does. So let's graph these, I guess, on the plane. So let's do 30, 60, 120, blah 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 blah. Oh boy. Maybe is there a way to like time lapse on YouTube? Oh god. Oh no, please. Okay. Stats about 30. I don't need to be very accurate. I just need to get the you know, the gist of things. The inside is just a complete mess. Oh god. I'm really botching these up, aren't I? Okay, well, there's our circle. Now we need to label it. Geez, this is going to be long. Here, I'm just going to label all of them. You can correspond, but I'm gonna try and go super duper fast. Actually, why do I need to label all of them? I'm only going to label some of them. You'll get the idea. Actually, okay, so here's what we're gonna do. We're only gonna label the first quadrant. Okay, and then when we have problems in the second quadrant, we will label those 45, 60. This is there we go. Everything in the first quadrant is labeled. Now let's begin with our actual trigonometry, right? So, well, first let's find, angles in the unit circle, which will be like a 2-minute lesson, okay? So let's find, how about 2 pi over 3, right? And our goal here is to not think about the angle. Don't think about what angle is 2 pi over 3. Think about how we can find it, right? Okay. And so let's find which of these is 2 pi over 3, right? Well, it's between pi over 2 and pi, so we know it's in the second quadrant, which is the top left. And well, we know it's between pi over 2 and 3 pi over 4. Therefore, it's this one, right? And then you can kind of, you can convert to angles, but what I like to do is never mind. You'll find a way. You should practice with radians a lot, because now I'm going beast mode, and I'm only going to be talking in radians. No more degrees, unless we are asked to convert to degrees, which we will do as a side lesson. Now, the real trigonometry. How to find basic. Well, this is done. We've already done that. How to find basic sine and cosine values. Let's go over what sine is, right? On the unit circle. Oh my god. So, I'll give it to you in its general form, and I will give it to you in the unit circle form. General form. Let's draw ourselves a triangle. Oh god. Not straight. Okay. Yes, I am. I'm not okay. Okay. Here we go. Yeah. There's our triangle, right? A, B, C. Let's say this is the angle, okay? So sine is going to be, let's write this. Let's write opposite over adjacent. And then for cosine, here's what we're gonna do is we're going to well, no, not opposite over adjacent, opposite over hypotenuse, right? Jesus Christ. And then so opposite over hypotenuse, right? Cosine is going to be adjacent over hypotenuse. And tangent, which we'll work with later. First, let's just start with sine and cosine, because tangent is very simple to calculate. Tangent is going to be opposite over adjacent, right? And so what do we want to do here is think about this, right? In terms of sine and cosine. Ignore tangent for now. Tangent, cosine, sine. And we're graphing all right triangles here. So let's do this. So let's find what's the opposite over hypotenuse. Well, it's the opposite, so B over C, right? Of this angle. So what's the opposite of this angle? Well, this is adjacent. This is the hypotenuse. So this is the opposite, right? And then if you're taking, say, this angle, then this becomes the opposite. Well, this is the adjacent, and this is still the hypotenuse. C is still the hypotenuse. But if we have opposite over hypotenuse, we can calculate this. Let's say it's a 3, 4, 5, right? A 3, 4, 5 right triangle. Sine is equal to 3/5. For this angle. For this angle, it's going to be what? 4 over 5, right? So sine is opposite over hypotenuse. Let's think about this in the unit circle, right? The hypotenuse which reaches out to the edge, is always going to be 1. So sine equal to the opposite. Now let's look at it this way, okay? Let's take, for example, let's take at 30, right? Let's draw a line down here, and we're always going to be taking the sine of one of these inner angles. So we're taking the sine of this angle, right? What's the opposite? Opposite. Well, it's just going to be the y value here, right? And that's going to work for any of these triangles. It's simply going to be the y value at that coordinate. And so, oopsie doopsie. So sine is equal to the y value. Now cosine is equal to the x value. You can figure this out. Adjacent over hypotenuse, plug it into the unit circle. Tangent is equal to the y value over the x value. Right? Opposite over adjacent. It's the same thing as sine over cosine, right? That's an identity, is that tangent is sine over cosine, because if sine is opposite, cosine is adjacent on the unit circle, tangent is equal to sine over cosine. That's a cool little identity. Okay. Let's begin. Let's find some trig values, okay? So let's start with the quadrantals, which are the 4 y and x, where y and x are straight, right? Like not whatever, they make right angles. So let's start at 0, right? Okay, here we are at 0. What is our y, sine and cosine? Well, the sine is the y value, right? So the sine is going to be 0, because it's at 1, 0. So if you find the coordinates of a point, you can find the sine and cosine if it's on the unit circle. This coordinates is 1, 0. The cosine is 1. The sine is 0, right? Because, excuse me, cosine is the x value. Sine is the y value. What at pi over 2? Pi over 2. Well, we're going straight up, right? That means our radius, our height is going to be 1. Our y value is 1, and we're staying on the y axis, and so we're at 0, 1. How about at so this is sine equals 1, cosine equals 0 at pi over 2. How about at pi? Well, negatives still apply here. Might not make much sense at first, but negatives apply. The cosine is -1, the sine is 0, right? And then same thing here. The cosine is 0 and the sine is -1. Down at 3 pi over 2. So now, the fun stuff comes. Now let's use, oh my god, excuse me, our what do you call it? Right? Special right triangles to find the sine and cosine at certain areas, right? Let's start with pi over 4, like somewhere, okay. Right, so we have, oh my god, okay, pi over 4. Right, let's erase this, we don't need this. Pi over 4. Let's draw a straight line down, right? Bam. Now this, as you will notice, is our 45, 45, 90 triangle, right? Because pi over 4 is equal to 45. So, well, and then this is a right angle, right? If we draw a line down, it's perpendicular to the x-axis, so that's going to be a right angle. Then we have a 45-degree angle in the middle, therefore this is, the top angle is also 45. So 45, 45, 90 triangle. We know that the hypotenuse is 1, right? Let's find the sine and cosine. Let's draw this baby over here, right? Oh my god. Let's go to 0, right? So 45, 45, 90. This is 1. This is x. This is x. Let's do a little algebra here. X squared plus x squared equals 1. 2x squared equals 1. Root 2x equals 1. X equals 1 by root 2. Okay? So that means that this value is 1 by root 2. This is also 1 by root 2. Let's go over here. Means this is 1 by root 2. 1 by root 2. Of course, we're trying to find the cosine and sine. The cosine is the x value. So the cosine, let me write this over here. Oh, baby. Okay, give me a couple seconds. Let me just divide this up here. Partition of India. There we go. And what is this? Okay, so we're gonna like fill our space so that I can take a really cool screen. Whoa! I didn't. Oh my god! Wait, really? Oh, darn it! It only fills in. Darn it! It only fills in the borders. I thought you could like take out a square like a big chunk. Okay, so we need all this. Now let's divide this up. What the heck? Oh, because I'm on eraser mode. Okay. Man, look at me go. There we go. So it's divided up. That's our workspace, right? So we know that. So let's save some space here, right? Cosine at pi over 4. And this is how you write it. Cosine, and in parentheses the angle, is equal to the value. Well, that's equal to the sine of pi over 4 in this case. Right? Equals 1 over root 2. There we go. Look at us go. Cosine of pi over 4 equals sine of pi over 4 equals 1 over root 2. So we find the cosine and sine. We can find the tangent. It's 1 over root 2 divided by 1 over root 2. They're equal. So tangent is equal to 1. I mean, I'm not going to write that, but, you can always calculate tangent if you have sine and cosine. Let's move on to the next part, which is, let's find the cosine and sine at pi over 6. Why can I not think? Right? This is 30. This is 30 over here, right? And this is 60, right? Because this is a right angle. You've drawn it down to the perpendicular line. That's 30, so the other side is 60 because they must sum to 180. So let's draw that triangle. How about over here? Okay, let's do this. Let's do a 30, 60, 90, please. And thank you. Right? Okay, what do we know our ratio is for 30, 60, 90s? We know if this is x, then this is 2x, this is root 3x, right? Now, let's calculate what it is if 2x, right, the hypotenuse, is equal to 1, right? So 2x equals 1. X is obviously equal to 1/2. So over here, x is 1/2. Then this thing is equal to root 3 by 2, right? And so now we have this as well, right? We know that this is the x value. And this is the y value. Right? And so now we have sine and cosine. Sine is y, x is cosine. Right? So sine of pi over 6 equals 1/2 cosine of pi over 6 equals root 3 by 2. That kind of does it. Well, you can calculate homework if you would like to practice this. Is you have your unit circle, right? How about you calculate values for let's do this. Let's draw this line here. Bam. Okay, so let's write this. Let's type with our fingers. Why is it caps lock? Okay, you guys are mean to me, so you get caps lock. Homework. Calculate sine and cosine at.
Wait, so Ham, we legit got every single.
Okay. Jesus, freaking idiot. Okay. Anyways, calculate sine at cosine at how about let's do 2. Well, let's do pi. Oh my god, I can't even do a forward slash or backward slash. Pi over. Jesus Christ. Okay, this is. I don't know how this happened. Over. Wait. Can I? Nope. Okay. I do shift. Oh, whoa. Nope. Okay. Over 6. Oh my god. Let's do 5 pi over 6. Alright, you can't do numbers. So, I'm very sorry for this inconvenience. 5 pi over 6. And let's do, how about, let's do something in the 4th quadrant. Let's do, what would that be? I'm trying to think of an interesting one. Yeah, sure, 11 pi over 6. Sorry. Over 6. And, what can we do for a challenge? Let's do this. Challenge. What the heck? Okay. Think of a way to go from the sine and cosine to the angle. What I mean by this is, try to find a way, if you are given the sine and cosine, to, if you're given the sine and cosine, try to find a way to get to the angle with special triangles. So 30, 60, 90, 45, 45, 90. And think of a way to get to the angle with, how about sine of x equals -1/2. Cosine at x equals √3/2. And so what you should try and do here, I mean, obviously you could find values for all the radians, you know.
Can you please stop?
And that would be, yeah, give me a sec.
Stop. Yeah.
I'm almost done.
I didn't do anything.
So this would be sorry for them, they're freaking annoying sometimes. So what I mean is that you don't just plug in values. You know, you can plug in pi over 6 to pi over 3, all the values, right? You can find one that where sine of x is equal to -1/2, cosine of x is √3/2. However, what I'd like you to do is to try and find the angle by drawing a triangle and then thinking about it, you know? And if you could do that, that would be awesome. This has been Charya. Hail, grrrrrrrgron, I suppose. And I'll see you next time.